So, hi everyone. So, welcome back to Electromagnetic Fields online series. And today in this session, I want to discuss how to find out the self inductance of solenoid and toroid. Self inductance of solenoid and toroid. So, basically, what do you mean by solenoid? Yeah. So, what do you mean by solenoid? Yeah, solenoid. Solenoid in the sense, suppose for example, if I take one rod like this, it is iron rod and it is coated with some paper, that is insulation is provided. It is coated with paper, and on this, so when I wound many number of turns, it is wound many number of turns like this. Yeah, so then it becomes the solenoid. That means whenever we excite this coil with some voltage V, so whether it may be AC or DC, it can able to produce the magnetic field. That means the current will be flows like this, and here magnetic field is produced in this fashion. This is called solenoid. So now let us we consider the solenoid of length L meters. Just let me draw this. Now we are going to find the self inductance of the solenoid. That is for that. So first let me take, this is solenoid. Yes, it contains n number of turns. Contains n number of turns like this, and the length of solenoid is L meters like that we assume. L meters like that we assume. It carries the current of capital I, and total number of turns are capital N, and turns per length. Turns per length is small n like that we assume. Yes, what is the small n? Small n is the number of turns per length. Turns per length. Okay. So here, and we know that let us assume the cross sectional area is capital A meter square. Okay. So then what is H here? H is equal to magnetic field intensity. Yes, H is given by Ni by L. H is given by magnetic field intensity is given by H is equal to Ni by L. But here we know that small n is equal to capital N by L. So hence here I can write this equation as small n into I. Small n into I. If H is equal to small n into I, then what is the value of B, magnetic field or magnetic flux density? That is, the magnetic flux density is given by B is equal to mu naught into H. And we know H is equal to mu naught into Ni. Ni. Okay. And then when we know the magnetic flux density or magnetic field, then we can able to find how much flux, that is magnetic flux, passing through the each turn of the coil. Each turn of the coil. So therefore, the magnetic flux passing through each turn of the coil is given by magnetic flux passing through each turn of the coil is given by pi is equal to B into A. B into A. So where B is mu naught N I into A. Okay, yes, so let it be, this is one equation. Yes, what is this value? Magnetic flux passing through each turn of the solenoid. Magnetic flux passing through each turn of the solenoid. So then, what is the magnetic flux linked with all turns of the solenoid? All turns of the solenoid. So that is the flux linked with all turns of the solenoid. Just let me erase this. Yes, which is given by the flux linked with all turns of the solenoid is given by pi is equal to, yes, pi dash is equal to mu naught N I A multiplied by capital N. That is total number of turns. So hence what we can do here is mu naught, where N is N by L A N I. So hence you can write the expression as mu naught N square A by L into I. This is pi dash. Pi dash in the sense the flux linked with all turns of the solenoid, which is also known as N pi. It is also considered as pi dash is equal to N pi. Okay. Then what is the self-inductance of the solenoid? Self-inductance of the solenoid is L is equal to N pi by I. Yes, which is given by self-inductance of solenoid is equal to N pi by I. That is, we know N pi, or you can also write pi dash by I. Yes, where pi dash is equal to mu naught N square A by L into I over I. So I get cancelled. Therefore, self-inductance of solenoid is given by mu naught N square A by L, where L is length of the solenoid and N is number of turns of the solenoid, and A is the capital A is the area of cross section. Area of cross section of the solenoid. Okay, na? Yes. Now let us see what is self-inductance of the toroid. Self-inductance of the toroid. Yes. Before going to the self-inductance of the toroid, first let us we know what do you mean by toroid. Toroid in the sense Toroid. Yes. What is this toroid? What is this toroid? Yes, toroid in the sense when the solenoid is closed by itself and bent into the shape of circular, then that can forms the solenoid. Sorry, toroid. Yes, what is toroid? When the solenoid is bent into the shape of circular, that will forms the toroid. That means let us we take like this. Yeah, so let us we assume this is the solenoid which is bent into the shape of circular. The flux is distributing like this. Yes, so here it contains n number of turns. contains n number of turns. And it is carrying the current capital I. It is carrying the current capital I. So let us we assume the cross section of the toroid is like this. It is A, which is in the shape of circular. Yes, where A is given by pi r square. A is equal to pi r square. So now what is the length of the toroid? The length of the toroid is equal to perimeter of the toroid. So that is L is equal to 2 pi, let it is capital R, 2 pi r. Okay, small r in the sense this value is small r, that is smaller, and it will be capital R, that is capital R. So now we have L you know, A you know. And according to the previous discussion, what is the self-inductance of the solenoid? L is equal to mu naught n square, A in the sense pi r square by L. L is 2 pi r. Yes, pi get cancelled. Yes, therefore, what is the expression for the self-inductance of the toroid? L is equal to mu naught n square r square by 2r. Yeah, this is self-inductance of the toroid and solenoid. Toroid and solenoid. Okay. So now let us see one problem. Okay. Yeah, the problem is like this. Yes, calculate the inductance of the solenoid. Calculate inductance of solenoid of 2800 turns wound uniformly over a length of 0.6 meters on a cylindrical paper tube. Paper tube 4 centimeters in diameter. The medium is air. Medium is air. Yeah, this is the problem. In the problem, what are the values he has given? He asked to find the inductance of the solenoid. That is L you need to find. What is an equation for the inductance of solenoid? L is equal to mu naught n square A by L. Yeah, this is the formula. And what are the values he has given? He has given the value of number of turns. N is there. So therefore N we know. Next, uniformly over a length of 0.6 meters. That means length. L is also he has given. L is also he has given. Then cylindrical paper tube 4 centimeters in diameter. R is given. R is given. Then what is the, sorry, D, diameter is given. You can find the R. That is D by 2. Radius is equal to D by 2. Yes, therefore we can find the area. Area in the sense A is equal to pi R square. A is equal to pi R square. A is equal to pi R square. So you know the all values. Now we can find, you can just plug it in this equation and you may get the self-inductance of this solenoid. Just should try and you will get the answer. Okay. Yeah, thank you for watching this. So we will meet again with the new concept soon, that is mutual inductance. Okay.